Okay, so welcome to section 1.2, which is propositions and logic. So propositions and a logic. Okay, so Boolean logic. Boolean logic. So this is, I'm kind of defining this. So this type of logic combines two statements, A and B or more. So it combines statements, capital A and capital B. So these are going to be placeholders for statements, so that are either true or false. So that are either true, which we're going to indicate with a capital T, or false, which we're going to indicate, of course, with a capital F. Okay, so into larger statements. So it combines the statements A and B that are either true or false into larger statements using, so into larger statements using the following. So using the first could be and, so A and B, so denoted by, oh shoot, let me get this, A and an upside down U, and then B, so, or alternately. Sometimes it's given as A and an upside down V and B. Both of these mean the same thing. They mean the word and. The next word, which we're going to use to combine the statements, is or. Technically, it's either or. And this is denoted by A and then, why am I having so many issues with my A today? So A and a normal U, let me make that U better, U, and then B, or alternately, the analogous definition would be A and a V, B. Okay, and let's note, how do I actually say these? So note, do this in light green. So note, so A and B is read aloud. A and B. Or alternately, or sometimes, let me put it that way, sometimes A intersect B. These both mean the same things when we're talking about statements. And how do I read A, U, B? So this is read aloud. A or B. Or sometimes A union B. Okay, and I want to put an asterisk here for this guy. So let me put the corresponding footnote here, which is as follows. How do I want to say this? when using or, think to yourself. To yourself. Either A or B. So if basically we're saying either or. So that's what I wanted to do there. Okay, and then I also want to give you the negation of a statement or set. So the notation for the negation of a statement or set. So of a statement or set is given by this little squiggly A, which is read aloud. Not A. Alternately, the equivalent is this blocky symbol here. This is also read aloud, not A. It's the same thing. I'm going to use the first symbol. I prefer it. Okay, so for example. Okay, so let's consider the set, or how do I want to say this? Let's let A be the set of integers 2, 4, and 6. And let's let B be the set of integers 3, 6, and 9. Okay, so find. So number 1, let's find the set A and the set B. And remember, we can also say intersect. Where do these two sets intersect? Okay, so let's look at set A. So set A is 2, 4, and 6. Set B, maybe I'll do this in orange. So set B is 3, 6, and 9. So if I look at where these two intersect or where they overlap, do you agree that the only thing they have in common is 6? So what is in A and B? So that which is in A and in B. Is just going to be the number 6. So that's what the AND symbol indicates, what's in both A and B. Okay. So subscript number 2. Let's do what's in A, either in A or in B. Okay, so if it's either in A or it's in B, well then it's going to be everything that is either in A or in B. Okay? So if it's either in A or it's in B, then that would be the set of A or B. So what's in either A or in B? Well, we have 2 that's either in A or in B, namely in A. We have 3 that's either in A or B, namely in B. We have 4 that's either in A or B, namely in this case A. We have 6 that is actually in both, right? Either in A or in B or in both, right? And then finally we have 9, which is in either A or B, namely in this case B. So this is the set of all elements that are either in A or in B. That is, we're putting everything into one big pot for the union, or A or B. Okay, so notice I only counted 6 once because it's like we don't need to count the number 6 twice. Okay, so let's go on to statements and, actually no, let me note that first before I go on. So let's note this. So note. So if an element appears in both sets, so if an element appears in both sets, so we only need to indicate it once in the union. We indicate it only once in the union A or B. Okay? Okay, so now let's move on to statements and conditions, or conditionals. So statements, what's a statement and what's a conditional? So statements and conditionals. Okay, so number 1. So a statement is an expression. So a statement, so this is somewhat of a definition, but so a statement is an expression that is either true or false. So an expression that is either true or false. Is either true or false. And how did we annotate true? With a capital T. Or false, how did we annotate false? With a capital F. So either true T or false F. So the second definition, or of what I'm defining here, is the conditional. So a conditional expression, so that's the second thing I'm really defining here. So is a compound statement of the form. So is a compound statement. Remember, a statement is something true or false. So a compound statement of the form. If P, then Q. Actually, I don't really need this comma there. So denoted by P and a arrow going to the right, Q. So this is read aloud, if P, then Q. So another conditional statement would be if P, then Q. Otherwise, or else, let's do S, and that's denoted. P, right arrow, Q, or S. Remember the V or the U both mean or, right? So where, what are P, Q, and S? So P, Q, and S are statements. And what are statements? They're an expression that is either true or false. Are statements. Okay, so let's see an example of this. So for example, if it is sunny, so if it is sunny, then we will use the air conditioning. Or then we will use the AC. Otherwise, we'll open the window. Otherwise, which is another way of saying else, we'll open the window. I'll open the window. Okay, so let's translate this into symbols. So a statement is either true or false. So I'm going to let P be the true or false statement. It is sunny. That's either true or false. It is either sunny or it is not. The next statement, let's use orange. We will use the AC. We're either going to use the AC or not. So let's call this Q. We will use the AC. Will we? Well, that depends. If it is sunny, we will. If it is not, we won't. Let me write that Q a bit smaller, and now let's look at the S. What color shall I use? Let's use purple. So we'll open the window. Let's call that S. We will open the window. Okay, so I claim that I can rewrite this statement as P right arrow Q. That alone says if it is sunny, if P, then we will use the AC. So remember, the arrow is the if then. So if P, then Q. If it is sunny, then we will use the AC. So this yellow is the if then. Otherwise, or the else, would be the or. I don't like that or. I'll make this a bit better. Otherwise what? Otherwise, or else, we will open the window. So if it is sunny, then we will use the AC. Otherwise, we will open the window. So let's do another one of these. So for example, so if my teacher continues, what shall I say? So if my teacher continues drinking caffeine, then I will be forced to drop. Otherwise, she'll drive me crazy. So otherwise, she'll drive me crazy. She'll drive me crazy. Okay, so let's do the same analysis with this. So my teacher continues drinking caffeine. So that's going to be my first statement. Will or won't my teacher? Well, either she will or she won't, right? So it's either true or false. So my teacher continues to drink caffeine. So either this is a true statement or it's a false statement. She either continues to drink caffeine or she does not. Then I will be forced to drop. So either I will be forced to drop or I won't. So this is true or false. So I will be forced to drop. Will be forced to drop. Otherwise, color did I use for S? Purple. So she'll drive me crazy. So this is my S. She'll drive me crazy. Okay, so I claim that I can rewrite this. The if then is an arrow, right? So if then I can indicate with an arrow going to the right. So if P, so if my teacher continues to drink caffeine, then Q, then I will be forced to drop. Otherwise known as else. So otherwise is the or. Yeah, wow, I don't like that. Let me draw this a bit better. Well, okay, I'm trying to draw this a bit better. Okay, well, otherwise, or else, she'll drive me crazy. So if my teacher continues to drink, then I'll be forced to drop. Otherwise, she'll drive me crazy. Okay, so hopefully this symbols is making sense now. So now let's note in Excel, which is like Google Sheets. So note. So in Excel or Google Sheets. So in Excel or Google Sheets, which is what I use because I can't afford anything otherwise. That's not free. So, or Google Sheets. The coding for if P, then Q, otherwise S is given by a capital IF, then a parentheses P, comma Q, comma S. Okay, so basically what you're going to say is, let's see, so you're going to have, I believe they are letters across the top. So you're going to have like A, B, C, D for your columns. So here's your A, D, C, D, etc. And then your rows will be 1. Let me make that one a bit better. So 1, 2, 3, etc. So you're going to have entries in each cell. So what we're going to do, we're not going to be coding, so don't worry about this, but we are going to be doing it theoretically. So let's say I just have entries in the first row. So let's say that this is, I don't know, how do I want to say this? 3, 6, 9. So what you're going to do in this entry right here, you would enter the code if, then parentheses, and then you'd have something about cell A1. So A1, let me draw that better. If the does something, comma, then maybe you'll do something to cell B1. Else, you'll do something to cell C1. So that's what the coding means. So hopefully by example, this will make more sense. So, for example, so translate if A1 is greater than 9, comma, A1 plus B1, comma, 6 times A1. Okay, so the if here is the if-then arrow. The first entry before the first comma is the P. The second entry after the first comma and between the second comma is the Q. And the final entry, actually the Q should be in orange, not purple, sorry, wrong color. So Q I did in orange. So Q, then the final guy S. So otherwise S is in. So how do I translate this? So P is equal to A1 is greater than 9. Q is equal to A1 plus B1. And S is equal to 6 times A1. So how would I translate all of this? I would say if the entry in cell A1 is greater than 9, comma, then, that's what that, add the entry in cell B1 to the entry in cell A1. Otherwise, multiply the entry in cell A1 by 6. Actually, I'll just write it as a number. Okay, so this is color-coded. We have our if by that big capital IF on the outside of the parentheses. P is the entry in cell A1 is greater than 9. Q is add the entry in cell B1 to the entry in cell A1. And S is multiply the entry in cell A1 by 6. Okay, so hopefully this makes sense. Let's do another one. One that's more applicable to real life, even though there's no real life anymore. So suppose you are taxed. You are taxed. 30%. 30% for all income less than 50,000. So for all income less than $50,000. And 40%. For all income greater than or equal to $50,000. So greater than or equal to $50,000. So express this in an Excel code. So express this in an Excel code. so first let's color code. So we know we are taxed 30% for all income less than $50,000. So let's say P is going to be A1 is less than 50,000. And then Q would be, actually, do you know what? How do I want to write this better? Let me do this a bit differently. So, for all income less than $50,000. So let's have P be equal to A1 less than $50,000. So if that's the case, then do you agree I will be taxed at 30%? So this would be A1 times, what's 30% as a decimal? It's actually 0.30. So if A1 is less than $50,000, so then I will be taxed at 30%. Otherwise, if it's greater than, I'll be taxed at 40%, right? So S would be A1 times 40% if it's not less than $50,000, right? So the way we would translate this, we know it's an if then, right? So if the entry in cell A1 is less than $50,000, then we'll tax at a 30% tax rate. Otherwise, we will tax at a 40% tax rate. So translating this into an Excel code would be a capital IF, open parentheses. What is the first argument? The entry in cell A1 is less than $50,000. If that's the case, then we tax at 30%. So then A1 times 30%. Otherwise, we tax at 40%. So if it's greater than or equal to 50,000, then we would tax at 40%. So this would be the corresponding Excel code for that. Okay, so the last thing I'd like to do in this section is to introduce what are known as quantifiers. So quantifiers. Okay, so the first type of quantifier is the universal quantifier. So the universal quantifier. Okay, so what is the universal quantifier? So this is denoted by a capital upside down A. So, oops, oh my goodness, what's going on? Oh, okay, so denoted by a capital upside down A, and this is read aloud for all. So the way I remember something universal would encompass everything, so for all, and because I'm using the word all, I can remember it's an upside down A, so for all. So, and this states that the entire set shares a common characteristic. So it states that the entire set, the universe of what we're dealing with, so the entire set shares a common characteristic. So shares a common characteristic. Okay, so that's the universal quantifier. And the second type of quantifier is called an existential. So the existential quantifier. Existential quantifier. And for those of you that have taken philosophy, you may have seen these before. The universal and existential quantifier. So, and this is denoted by, and much like for all is an upside down A, existential quantifier is denoted by a capital backwards E. So denoted by a capital backwards E, read aloud. So read aloud. There exists. Okay, well, I'm having so much issues with this. Okay, so there exists. So E for exists, the existential quantifier. So states that at least one element in the set. So states that at least one element in the set. So states that at least there exists, right? So it has to, one guy has to have it. So at least one element in the set. One element in the set. In the set has the desired characteristic. So has the desired characteristic. Okay, so what do I mean by this? Let's do one last example before we go. So for example, so let's let P be the statement, a cat is good. So translate the following. So number one, for all P. Okay, so this is a universal quantifier. This upside down A is for all. And then P is a cat is good. Okay, so this is really, if I were to translate it, all cats are good. All cats are good. Right? That's what this is really saying. Right? For all, a cat is good. So we have to kind of translate the English to see. So backwards E, P. So now this is backwards E. There exists. And then a cat is good. So that I would translate that as there is a good cat, right? There is a good cat. Okay, so hopefully that makes sense. Anyways, I will see you guys in the next section.